Hi, Professor. Today I'm going to show you an example of how to use Leviatom and how to use the StreamNet. Suppose we have 11 Leviatom machines, then they are performing attestations between each other, and their attestation relationship is at like this shows. And once this attestation is performed and the data is actually uploaded into the StreamNet machines, which we use these numbers to represent the StreamNet machines. There are 7 StreamNet machines. If you like, you can have 1 StreamNet machine per each Leviatom machine. And this information is uploaded into the StreamNet machines. Since StreamNet machines are connected to each other, this information will be replicated into each StreamNet machine. And each machine will have exactly the same view of the attestation information. And based on this information, we can calculate the scores of each Leviatom machine, and we can elect 3 supernodes. For example, if we rank the supernodes simply by the number of the approvers of the machine, we will have the ranking as this shows, which is B, E, F, because B has 7 machines approving him, and E have 6 machines approving him, and F have 2. However, we can see that the nodes that are approving B and E are G, H, I, J, K. Of these 5 machines, they are not approved by anyone, and which means that they can be cheating. They can be the machines that are scam, are for fraud. And because of this, we need to adjust our scoring metrics, because the one that is more trustable approving me will be considered higher, considered higher weight. So we use the page rank to do the score. So if we use this page rank to rescore this Leviatom world, we will get the score as B has score of 0.39, C has 0.34, and E have 0.08. And we get this new ranking. Surprisingly, C only have B approving him, and it has a very high score. The reason is that B is considered by the network as a very trustable node. If B approves anyone, it will be this approval relationship or this attestation relationship will be considered as a strong tie. So after we finish this example, we will go through a real application example. Now we have 7 StreamNet machines running on the backend. We have deployed in the real physical machines. For instance, you can see that in these machines, there are 2 Docker services running. One is IOTA node. This service is the StreamNet application, and IOTA client is the application built upon it, which can receive the Leviatom request. So now we also have a web page. Now we perform attestation between A and B. Now we select node 1 to upload the score, and we have A and B with the score of 0. And now let's submit this information, and this is successful. And if we come to StreamNet, let's choose node 1 and choose the StreamNet port, we can get this information which is represented as a block If we click on this block, we can get the content, the real information that is stored on this block. We can see that attest A has performed attestation on B with a score of 0. And we can do this in parallel. Let's log on the remote machine. And we see that the script like this. This is exactly the same representation as the figure here. And now let's execute this script. It's done very quickly. And let's come back to this web page. And if we query the StreamNet again, we will see that this is a DAG. It's a digraph, because the requests are sent to the DAG to different machines at the same time in parallel. So this machines will organize this data and replicate this data, and the relationship will be looks like a DAG. If we click on one of the nodes of the block, we can see the data that is stored in the block. And if we want to know the order of the data, we can sort it into the same, sort it into a chain. No matter which machine we are going to, we will always get the same data and get the same chain, which ensures that each Leviatom machine, no matter which StreamNet is accessed to, it will always have the same global view and have the same global ranking. So now let's come back to the ranking. We click on any nodes and choose the Leviatom port, and we want to get the top 3 rank of the Leviatom cluster. We click on the get rank. It will shows this score BCE, shows the ranking. If we want to know all the 11 machines, the score will be like this. And we can also see these relationships. So let's try node number 6. Gets 4. It will be like this. So no matter which node you go into, you will always get the same score and same ranking. And this ranking will help us to elect the top 3 nodes from the network and commit the blocks. That's it. So there are also some issues in this example and in this demo. For instance, just as you have mentioned in the email, so what's going to be stored is in this attestation information is very critical and very important. How to make sure that it's the information is secure is very, very important. And how do we apply this the trustable computing technology to this attestation is very critical. So that's the reason why we need expertise in the Oxford team to help us to make this demo into a real product. Thanks.